Hi, this is exercise video number 5, and for my exercise today I did a little bit of arms and back and also a little bit of cardio as well. And so I did bicep curls, barbell bent over rows, dumbbell rows, and bench press. And then I ran 1 mile with a pace of 8 minutes and 15 seconds outside. And so what was happening in my body during this exercise is my body was converting food nutrients from what I ate today into usable energy. And so during my exercise at the gym when I was lifting weights, I kind of had a moderate intensity. It wasn't as high intensity as, say, my mile, for example. So I would say that my body was most likely burning fats more than carbs, and that's called glucose sparing. My body was sparing my glucose to wait and use that until I actually need it in more intense exercise. And so whenever I was at the gym, my body was converting fat into acetyl-CoA to feed into the Krebs cycle and then eventually lead to oxidative phosphorylation to end up with ATP from NADH, FADH, and GTP. And whenever I was in my run, my body was most likely doing the glycolytic system predominantly. And so what was happening is my body was most likely burning carbs more than fats, and the carbs were feeding into the Krebs cycle, feeding into glycolysis, turning pyruvate into acetyl-CoA, and then that was fed into the Krebs cycle and then went to oxidative phosphorylation. And I noticed during my run that I was feeling a lot of burn. It was hot outside, my legs were tired, my muscles were burning, and this can be attributed to pyruvate being converted into lactate, and then the hydrogen from NADH being donated to that lactate. And so the hydrogen buildup in my muscles is what caused that burn whenever I was running. And that lactate goes to the liver to go through the Cori cycle and then eventually turns into glucose and is fed back into glycolysis to keep my body continuously producing ATP to be able to sustain that exercise.